So okay, in the previous class we have already started the support reaction. So after long time you need the some of the brief introduction or the glance regarding the support reactions. So let me discuss briefly. So what do you mean by the support reaction? So what are all the types of supports we have discussed? So there are 4 types of supports we have discussed. So one is the simply supported beam, or we can also call it as a simple support, having the number of reaction is 1. It's nothing but, so it is only restricting the moment along the y direction. So if you suppose if you are having any beam, simply supported means you need to show the support like this. So how many reactions? So here I am writing the number of reactions. The number of reactions for a simply supported beam is 1. So and in some cases we are getting the hinged support. So that is type of support is hinged support. So while explaining regarding the types of supports, I have given you the example of a door. So we can rotate the door, we cannot move the door along horizontal direction, we cannot move the door along the vertical direction. So whatever the support we have provided for the door, that is what a hinged support. So means it is restricting the moment along the x axis as well as y axis. So therefore number of reaction for a hinged support is 2 here. So here if hinged support is given in the problem means you need to write the 2 reactions, one is vertical reaction and one is horizontal reaction. So means if we are provided the hinged support means it cannot allow the any object to move in a horizontal direction as well as the vertical direction. Hence the number of reactions are 2 here. So and another support we have discussed, that is the roller support. So how many reactions for a roller support? So this is what the representation of roller support. So means if the roller is there means it can rotate and it can move in the horizontal direction, but it cannot move along the vertical direction here. So therefore for the roller support the restriction is only on the y direction. So therefore the number of reaction for a roller support is 1. So suppose in a beam, so if they have mentioned as a roller support of, if they are given the notation like this, so how many support reactions you need to write? So you need to write the only one support reaction, that is vertical support reaction. So finally the another the important type of support, that is fixed support. So this is what the representation of the fixed support. So means it is fixed along all the directions. So there is horizontal movement is also not possible, vertical movement is also not possible, and it should not turn also. So therefore, so if the fixed support is given in the problem, so we are getting the number of reaction as a 3, and you need to write the 3 reactions for a fixed support. One is horizontal, one is vertical, as well as moment also. So in order to draw the free body diagram, so we need all these types of support. So here what is important? So here it is important to remember the number of reactions here. So you can observe here for simply supported it is 1, and for hinge it is 2, roller 1, and fixed it is 3 reactions. So these basic things you need to remember in order to solve the problems on a support reaction. And along with this there are some types of loads we are using while solving the problems. So what all the types of load means, we are having the 3 types of loads. One is the concentrated load. So what is this? That is concentrated load. And another type of load is UDL, uniformly distributed load. So the representation of UDL is like this, and that is uniformly distributed load. And another type of load we are observing is that is UVL, that is triangular form, that is uniformly varying load, that is UVL, uniformly distributed load and uniformly varying load. So this conversion also I have explained, just I will give you the glance regarding this. So if the UDL is given, so suppose this is the UDL given in the problem. The magnitude of this UDL, suppose you just take 10 kilonewton and it is per meter it is acting. Suppose if you want to calculate, so suppose if you want to convert this UDL into point load, you just take this as a 2 meter of span. So if you want to convert this uniformly distributed load into the point load, then what you have to do, you have to multiply this magnitude into the span at which the UDL is acting. So means if you want to convert this UDL to point load, the converted point load is 10 into the span where it is acting is 2, that is 20 kilonewton is a converted point load. So then you need to act exactly at the center of the beam here. So means 2 meter means the center is here 1 meter. So exactly at the 1 meter of distance your converted concentrated load is acting. So means this is what the conversion of UDL into the point load. So suppose in the problem if UDL is given, so then magnitude into the span where it is acting you just multiply it, and the point of application, so where you need to apply, exactly at the center of the span where the UDL is acting. So this is what the conversion of UDL. Yes, is it clear? Yes? So then you can see here the another type of load is there, that is uniformly varying load. Suppose uniformly varying load is given in the problem. So this is what the uniformly varying load. So whatever the magnitude, so suppose you just take it as a 10 kilonewton, again it is in terms of meter, kilonewton meter. So if you want to convert this UVL into point load, so you just consider this as a 2 meter. So in order to convert this uniformly varying load into the point load, you need to apply the formula for the area of the triangle, that is it is resembles as a right angle triangle. Off into base into height will become the converted point load. So 2 will be cancelled and 10 kilonewton is your point load. So and where you need to act, so this is very important here, you need to consider, so if you are measuring from 90-degree side, so then you have to consider the distance 1/3 of base. Base is how much? 2. So if we are applying the load from this other than 90-degree side, so then it is 2/3 of base. So means you need to apply this 10 kilonewton, not exactly at the center as in the UDL. So you need to apply 1/3 of base from the 90-degree side. So otherwise if you are taking the reference of other than 90-degree, so then it is 2/3 of base. So like that you need to convert UDL into the point load as well as UVL into the point load. So using the support reactions and using this conversion of the point load, that is UDL into point load, UVL into point load. So you need to solve the problems on the support reaction. So there are different types of beams are given, so along with a different loading condition. So you need to find out what is the value of RA, what is the value of RB for the different problems. So these things I have already explained you, but it is I am explaining once again for the glancing purpose. So let us move for the what are all the problems we are seeing. You just see here the different types of loads and the conversion that we have already discussed. You just have a glance on it. Types of support is there: roller support, hinged support, fixed, and simply supported beam. There are different types of beams. And the concentrated load, only point load is which is acting at a single point, then it is concentrated, UDL and UVL. So conversion I have already explained you conversion here. You just observe 20 into 3, since 20 is a UDL acting at the 3 meter of span, therefore 20 into 3 6, and where you need to apply, you need to apply exactly at the center. So similarly uniformly varying load is there. How we need to convert, that is off into base into height, and from 90 degree side it is 1/3, and from other than 90 degree side it is 2/3 of base. So like this you need to have the conversion of the different types of loads which is acting on a beam. Is it clear? Are you following?
Yes, ma'am.
Okay. So now we can see here, so this is what the somewhat different problem. So based on the given support only, you need to decide which type of support, and you need to write the number of reactions here. So this is the typical problem. You just go through this. What you need to determine the reaction at A and E point on a beam as shown in figure. The figure is given. So you need to determine the support reaction at a point A as well as point E here. So which type of support you can see at point A? So what is the type of support point A? Which type of support we are having? Point A, which type of support it is? So this is hinged support. So what I have explained earlier. So this is what the hinged support. So if the hinged support is there, how many reactions we are getting? How many reactions for a hinged support? See, just now as I have explained, just see here, there are different types of supports are there. So now in the problem we are having the hinged support, number of reactions are 2, one is horizontal and one is vertical, right? So you can write for hinged support 2 reactions, and another side we are having the roller support, that is only 1 reaction. So you can observe here at A point we are having the hinged support, so therefore you can take it as, that is R A X. So for your reference, because X, so R A Y this is, and this is R A X, 2 reactions. So and at point E we are having roller support, so therefore the number of reaction is only 1, so you can call it as RE. Clear? So now the support reactions we have written. So as it is, whatever the load it is given, so that you need to write on the beam. So now 100 kilonewton is there, you just write the 100 kilonewton as it is. And again here at the point D we are having one inclined force, just write the inclined force here. So and here we are having the UDL. So I have told you how to convert UDL into the point load. So that is magnitude into the span where it is acting. So magnitude is 20 and it is acting at a 3 meter of span. So then you need to convert this UDL into the point load, and where you need to apply exactly at the center of this span. So what is the point load here? 20 into 3. 20 into 3, 60 is your point load. You just mark the different distances where it is acting. So from here to here 3 meter, 3 meter and 3 meter, that is 3, 3 and 3 here and 3. So this is point B, point A, point C, D and E. So now we have converted this UDL into the point load, and you need to apply exactly at the center of this span, that is from B to this point it is 1.5, and from here also it is 1.5. So because entire we are having 3 meter, so 1.5 and 1.5. So along with that you need to show the moment also. At the point C we are having one moment, clockwise moment. You need to show that moment also. Magnitude of that moment is 100 kilonewton meter. So and inclined load is there, that is 200, and it is making an angle 45 degree. So write as it is here. So now what we have did, so we have written the free body diagram of a given beam by writing the support reaction as well as the number of forces which is acting on a beam. So just I will write the magnitude. This is 100, and this is converted UDL into the point load, that is 60 kilonewton. Then moment is there, and 20 is the inclined force which is acting. So now this is what the free body diagram which is ready. Now the thing is you need to apply the equilibrium condition, and you need to find out the what are all the support reaction. So what is the equilibrium condition? First the equilibrium condition we are having summation of horizontal force is equal to 0. So just see in the figure how many horizontal forces are there. So RAX is one horizontal force we are having, and remaining are vertical forces. One inclined force is there here, 200. So we know the resolution. So if 200 is an inclined force, we are resolving this force into the two component. Horizontal component become cos because it is making an angle 45 degree with respect to horizontal. Therefore 200 cos 45 is your x component, and 200 sin 45 is your y component. So now we are having one horizontal reaction. So that is RAX is along the positive direction. I have shown you the sign convention. So this is what, just I will write the sign convention here. So that is upward is positive, this side positive, and negative negative. So RAX is positive, and this 200 cos 45 it is negative. We just write 200 cos 45, that is equal to 0. So in the entire equation RAX is only the unknown. By solving this you will get the what is the value of RAX in terms of kilonewton. So that is one equilibrium condition is over. Next you need to apply the second equilibrium condition, summation of vertical force is equal to 0, right? So just see now, observe the free body diagram. RAY is vertical force moving upward, this one positive, and RE is also vertical force moving upward, positive, and 100 kilonewton is there coming downward, therefore it is negative, and 60 kilonewton, that is converted UDL into point load is 60 kilonewton, that is coming downward, therefore it is negative, and vertical component of this inclined force, that is 200 sin 45, 200 sin 45 is equal to 0. So how many totally? There are 3 vertical forces are coming downward and 2 vertical forces are moving upward. So this is equal to 0. So by solving this you will get one equation, RAY plus RE is equal to some value we were getting, still we are having the both are unknown. RAY is also not known, RE is also not unknown. So now in order to find out this, again we need to apply the third equilibrium condition what we are having, that is summation of moment at any point. So now I am taking the moment at A point, so therefore moment at A is equal to 0. So what do you mean by moment here? How you are going to calculate the moment? How you are taking the moment of any force about point A or any point? Have you forgotten all the things? Moment is nothing but what? So it is force into the perpendicular distance, right? Force into perpendicular distance. So now we are taking the moment exactly at point A for RAX and RAY passing through the point A only. There is no perpendicular distance, or the perpendicular distance is 0. Therefore, we are not getting the moment due to RAX and RAY. So, because which is acting at the same point where we are taking the moment. So, and again one more thing you can observe here, another we are having vertical component of this inclined force, horizontal component of this inclined force. So, just observe here, this horizontal force line of action is also passing through the point A. We are again not getting the moment due to this horizontal force. So, now you need to write moment due to 100 kilonewton, 60 kilonewton and vertical component of 200 and the RE about point A. So, let me see how we are going to write the moment. Just observe here. See here, what are all the values we are having. Moment due to 100 about point A. So, 100 perpendicular distance is you can observe in the question.
Okay, ma'am.
Yes. See, perpendicular distance is 3 here. It is given, that is 100 into 3 is the perpendicular distance. And what is the direction? Direction of 100 kilonewton about point A. So, whether it is clockwise or anti-clockwise? Direction of 100 kilonewton about point A. So, whether it is clockwise or anti-clockwise? So, you just observe in the figure. So, 100 is a force, point is here. So, if you want to reach this point, the 100 should come in this direction, that is clockwise. Therefore, 100 into 3 moving in the clockwise direction, therefore, it is positive. So, and another force we are having 60. 60 is a force and which is acting at this point, that is at the exactly at the center we are having the 60. So, that is 3 meter from here, 1.5 meter from here, that is totally 4.5. So, from this point to A point totally 4.5 you need to consider, that is 60 into 4.5 is the perpendicular distance. So, remaining force is vertical component of 200 kilonewton. So, we are having the vertical component of 200 kilonewton as 200 sin 45 is a force, and perpendicular distance means from this point is nothing but just I will show in the question. So, vertical component means which is acting here. From the point D you need to consider the perpendicular distance up to the point A, that is from here to here, 3 plus 3 plus 3, therefore 9 you need to consider. Again, in order to reach the point A, it should come in this direction, that is clockwise, therefore it is positive. So, remaining the last force RE we are having. So, RE is a force that is acting here. In order to reach the point A, it should come in this direction, that is anti-clockwise, therefore it is negative, minus RE into perpendicular distance is how much? That is from E point to A point. 3 plus 3 plus 3 plus 3, that is 12 is equal to 0. So, now you can observe this equation. So, in the entire equation RE is only the unknown. By simplifying we will easily get what is the value of RE in terms of kilonewton. By substituting this RE in equation 1 you are getting the value of RAY. So, like that you can easily find out the what is the support reactions whenever the beam is subjected to the different types of loading. So, just I will show you this problem. You can observe here. So, this is solved problem is there, you just go through this. So, this is what the same problem. And one more thing here, just see, while calculating the moment, in the question they have given the moment also. 100 Newton moment is also there. So you just see whether it is clockwise moment or anti-clockwise moment. So along with this moment you need to add the moment also. So because at the C point the moment is given here. So and it is clockwise moment. So therefore plus 100 you need to add. So suppose the moment is given means, so while calculating the summation of moment is equal to 0, you need to add the given moment also. Then you need to simplify, then you will get the whatever the support reactions, so that we can observe. So this is what the problem you can see here as I explained. So here 60 kilonewton is converted, point load is there, summation of Fx, Fy you need to apply, and this is equation 1. Take the moment and add the 100 Newton whichever it is given. So finally you will get the support reactions. So like that you need to solve the problems by considering the different support reactions which is given in the problem. Yes, is it clear? So let me continue the remaining problems in the